Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about composition relationship in object-oriented programming. In this video I will explain what is composition relationship, how to model composition relationship using objects, and what are the key characteristics of composition relationship. So if you are willing to learn what is composition relationship, then this video is for you. So make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, so let's begin this video with the very first question, that what is composition relationship? Well, it is a kind of relationship which represents a strong relationship between objects or entities of the real world. So let's understand this relationship with an example. So in real world, what happens? We have a car object or car entity, and this car has 4 wheels and 4 doors. Now the challenge is we want to model this relationship using UML. So how are we going to model this relationship? Let's see it. So we have a car here and we have wheel here. So wheel is a class and car is also a class. So to represent a strong relationship or composition relationship between car and wheel, we use filled diamond symbol, okay? And similarly, to represent a relationship or a strong relationship between car and doors, we use filled diamond symbol to represent. So this is how we can model the relationship between car, wheel and door using filled diamond in unified modeling language. Now this brings us to the question that why are we calling this model a composition relationship and why are we calling this a strong relationship? So guys, there are some characteristics or key points that we should aware of. So the first one is this relationship represents as a relationship or a part of whole relationship. And why is it so? Because we can say that wheel is a part of car and door is a part of car, right? And on the flip side, we can say that car has 4 wheels and car has 4 doors. But the question over here is, which property makes this relationship a strong relationship? So there are few reasons for making this relationship strong. The first one is a part cannot exist without the whole. And this is true that wheel cannot exist without car and door cannot exist without car. And this is true, right? And second point is all entities depends on each other. And this is also true that wheel is also dependent on car and door is also dependent on car. Now without car, we have no use of doors and we have no use of wheel. What we would do with the wheels and doors if we do not have car, right? Makes sense? Now the next point is they do not have their own life cycle. So which means that when we destroy the car, the wheel and car will get destroyed automatically. So they do not have their own life cycle. When we create a car, we create wheel, and when we create car, we can create door. Without car, there is no use of door, so we are not going to create door without a car. As simple as that. And the next point is they cannot survive individually, and we can also call this type of relationship as death relationship. So as I said that when we destroy the car, the wheel will not survive and a door will also not survive. Okay, and we can call this as a death relationship. Why? Because when we destroy the car, the wheel and door automatically gets destroyed. So that is why when the car is dead, which means the wheel and also is dead. Okay, so these are all the reasons why we call this relationship as a strong relationship, and we call it composition because car is made up of wheel and door. We can also say that car composed of wheel and door, right? Makes sense? Now the last thing is there is a ownership exists in this relationship. So we can say that the owner of wheel and door is a car, or we can say that car is a parent of wheel and door, right? This is so guys, this is all about composition relationship. I have shown you what is composition relationship, how to model composition relationship using UML, and what are the key characteristics of composition relationship. Now let me take you to my IDE to show you hands-on practical demo of how we can model composition relationship in object-oriented programming using objects. Alright, so we are on the IDE. Now to model the relationship or composition relationship between car, wheel and door, we have to create classes for car, wheel and dome respectively. So let's create first class, that is a car, okay, and car can have one name. So let's create one property, of type string, and the name of this property is name. Okay, let's create one constructor to initialize this property. Great. Now let's create one more class with the name wheel. Okay, WHEEL, and we can have one property of this wheel as size. So let's create one property with the name integer and give it a size and give it a name size. Okay, let's create one constructor to initialize this property of wheel class. Okay, now again we need one more class which represents door. So let's create a door class, and door can also have size. I'm taking this example just to make you understand how things works. Okay, the type of this is int, and let's give it a name size. Okay, let's call the constructor. Okay, so this is how we are going to initialize the size property of door class. Now it's also better to override the toString method of this class. Okay, so that we can print the string representation of this object. Similarly, let's do here also. So by now our wheel and door class is ready, and we can now use wheel and door class inside of car class. Okay, here we have to define two more properties that will store wheels and doors, right? So let's create private, and a car can have multiple wheels and car can have multiple doors. So in that case we have to use a list variable, and this list is going to hold multiple wheels, and let's give it a name wheels. Okay, similarly we need one more list, and this list is going to store all the doors of the car. So let's name it as doors. Okay, now let's initialize this property. Wheels is equal to new array list of wheel. Similarly, let's initialize doors with array list. Oh my god, doors of DOOR, door. Okay, now we have initialized both the properties wheels and doors. Now we need two methods which will add wheels and doors into this car object. Okay, so let's define one method, public void add wheels. Okay, and this method takes one parameter, that how many wheels we want into this car. So let's give it a name I. Now we are going to run a for loop to add wheels into this car. Okay, let's initialize j is equal to 0. Okay, j is less than I, j plus plus. Okay, let's add wheel to this car. So wheels dot add new wheel of size, let's say 4, anything, just for the demo purpose. Okay, this is how we add wheels to this car object. Similarly, we need one more method to add doors to this car. So let's define one method, add doors. Okay, add doors. Okay, this method also takes one integer which represents how many doors we want in this car object. Similarly, let's call doors dot add, and let's create a new object of door with the size of, let's say, 6, anything, just for fun. Okay, now our wheel class is ready, door class is ready, and car class is ready, and this car class contains a list of wheels and the list of door. Okay, and we also have name of this class. Now let's create an object of car class and see composition relationship in action. So let's call car, give it a name, car is equal to new car, and give it a name, let's say BMW. Okay, one thing we forgot to mention here, that I have to override toString method of this class. Okay, so that we can print the string representation of this object. Okay, so our car object is created. Now let's add 4 wheels into this car by using this method. Give it a 4, and let's give it 4 as doors. Okay, so let's add 4 doors into this car. Alright, now we can print this car object onto the screen. Okay, run the program and you will see that the composition relationship in action. So we have car with the name BMW. This car has 4 wheels of size 4. 1, 2, 3, 4. And we have 4 doors. Doors is equal to door 1, door 2, door 3 and door 4. Now if we destroy this object, let's say car is equal to null. This is how we destroy object in Java. And if I print car object again, then you will see that the car object is printed on the screen first of all, and then we have destroyed the car object. And then you will see that when we destroyed the car, the wheel and door also gets destroyed. So that is why we call this type of relation as a strong relationship, that all the parts are dependent on each other and a part cannot exist without the whole. So once the object of car gets deleted, all its part also gets deleted automatically. So guys, this is how composition relationship works in the object-oriented programming, and this is how we can model composition using objects in object-oriented programming. So I hope by now the composition relationship is clear to you, and now you have a strong hold over relationships. So guys, this is all from my side for this video. If you like this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon, so my friend, you never miss any upcoming videos. Thanks for watching. See you in the next one.